Good morning, ladies and gentlemen. This is Mr. Rowe. We're looking at intermediate algebra. This is part B. We're going to focus on lesson 1. This is a lesson on exponents. So we're going to go through the rules first, and then we're going to apply them to some problems that are similar to the ones you're going to see in your lesson. So let's get started. So let's start off by looking at I said laws, but it's the rules of exponents. So there's a few, so let's go through them quickly. These are in the lesson, so you can review these through the lesson. All right, so here's the one that's probably used the most. It's the product of power rule. Product of powers. And what it says is that if you have any number to a base, and you're multiplying it by the same base but a different exponent, you're simply going to add those exponents. So for example, if we had x to the 7th times x to the 6th, we're going to get x to the 13th. 6 plus 7 is 13. So that's the product of power rules. All right, then there's the power to a power. And I'm going to show you this a couple different ways. So what this one says is that if you have something to a power and then it's raised to another power, you're going to multiply those powers. So that's the power to a power. Now that also can look like this. So let's say we had a couple things. In the power that's raised to a power. We're going to use kind of like distributive property. We're going to apply that power. So P in this case will be applied to both terms, x to the m and y to the m. So we'll get x to the m p and then y to the n p. So we give that to both things. So make sure you understand you have to give it to both terms. So that's the first two rules there. And I'm not going to go through all of them. I'm going through the important ones. So there's going to be some that I'm going to skip over, and I'm going to skip over them on purpose. So here is the division rule. So division, so let's say we had a to the m divided by a to the n. We're going to subtract these exponents. So a to the m minus n. So for example, x to the 7th divided by x to the 5th. We're going to subtract those exponents and get x to the 2nd power. And then there is the zero property, zero rule. So what the zero rule says is that if you have anything to the 0 power, no matter what it is, it's going to equal 1. Anything to the 0 power. Just thing to the 0 power is going to equal 1. So these are kind of rules I'm going to use as we go through the rest of the examples. Please go back and refer to these if you're still needing, just kind of a refresher with those. This is something you probably saw in an earlier class somewhere. Hopefully you did anyway. So here's our first example. This is x to the 6th raised to the 4th power. Well, that's that second rule I showed you, the product to power, or the power to a power rule. So what I got to do here is I've got to multiply those two exponents. So that's simply going to give me x to the 24th power. That's it, done. That's as easy as these get. So let's look at another example. So now this one, I'm going to have to apply a couple of rules. I notice I have a negative exponent, so I'm thinking about that negative exponent rule. I've got a power in parentheses raised to a power. And I've got two things in the parentheses, so I know I have to apply that power to both terms. So what I'm going to do is I'm going to apply that power to both things inside. And so that's going to give me x to the 4th. Remember, those assumed that x has the first power exponent, so 1 times 4 is 4. And then we're going to have y to the negative 5 times 4, which is negative 20. Now, general rules are that you do not leave negative exponents. So we have to make sure that all of our exponents are positive exponents. So we do have to apply that negative exponent rule. So what that negative exponent rule says, and I kind of briefly told you what it means, but what it means is that something has to move. So if you have a negative exponent, it has to move somewhere to turn positive. So in this case, I've got x times y, node fraction, right? So there's no denominators, just a numerator. So we can pretend like this is over 1. I can now move that negative exponent down to a denominator, making it positive. That's how you apply that negative exponent rule. So this will be simplified to x to the 4th power over y to the 20th. That's how you apply the negative exponent rule. So make sure you never leave anything with a negative exponent. So let's take a look at the next example. And I think it kind of emphasizes the deal here. Both of these have a negative exponent. We cannot leave negative exponents. So both things will have to move. This will have to move to the top, the numerator. This will have to move down and become a denominator. So they're basically going to flip here. So this will be y to the 9th over x to the 8th. And that's a done deal on that one. All right, here's the next one. Now I've got a lot going on here. I've got inside parentheses, I've got some negative numbers, I've got a negative exponent, and outside I've got a power. So how you apply the rules is up to you. I'm telling you how I think it's the easiest. So what I'm going to do is I'm going to apply that negative exponent that's outside. I'm going to apply it, and you have to give it to every term. So it has to go to that, it has to go to that, and it has to go to that 7. So everything will get the power. So we're going to have negative 3 to the negative 1st power over 7 to the negative 1st power, and then x, and here's where you multiply. Negative 1 times negative 4 is positive 4. So that becomes a positive 4. And now we have to move things based on negative exponents. Only negative exponents move. Anything with a positive exponent is perfectly fine to stay where it's at. So this has to move, and this has to move. The x to the 4th stays right where it's at. And you notice I included circling the negative because the negative goes with the value. So over here, we end up with 7 as a numerator, because it's going to move up. Negative 3 in the denominator, because it's going to move down. And then that x to the 4th will stay where it's at and not move. So that is the final answer. So apply the power outside to everything inside first. Then move terms based on the exponent. That's how I think it's easier. There's other ways you could flip this thing first. Sometimes it gets more confusing the more rules you apply. My philosophy is the fewer of these rules you apply, the better you are. So now here's the next example. Now don't get confused with negative numbers and negative exponents. This 5 is negative. It's not a negative exponent. This 4 is negative. It's not a negative exponent. So we're going to use the power product of power rule here. And we have to do it with each term. So that means each term we have to follow that rule. So I'm going to multiply negative 5 and negative 4. That's going to give me positive 20. I'm going to multiply the x to the first power with the x to the fifth power. And I'm going to add those exponents. Remember, this x has a assumed 1 power. So 1 plus 5 is x to the 6th power. And then we have the y to the 6th and the y. Same rule here. I got a y to the first power right there. I've got y to the 6th power. So that's going to give me y to the 7th power. So my final answer here is 20 x to the 6th, y to the 7th. So just apply those rules, multiply numbers always, and then apply the exponent rule to each thing of the exponents. All right, so here I have a fraction. And what I like to do here, this is something I called comparing. And so we're going to start off by dealing with the numbers first. Always deal with the numbers. Let me change colors. I don't like using black when I do this. Let's use red so we can see some change there. I want to treat that like it's a fraction, and I want to reduce it. So 48 over 72 will reduce. 4 goes into both. 2 goes into both. What else goes into both? So figure out the biggest value that goes into both. And if you're not sure, you can always pull up your calculator and watch what I can do here. So I've got negative 48 divided by negative 72. And if I hit this math button, see this first option? That will simplify all of my fractions. And look at that. That becomes 2/3. So what did we divide by to get all that? Well, what's 48 divided by 2? So it looks like 24 went into each. So I reduced everything by 24 to get 2/3. So the fractions will actually reduce to 2/3. Now here's where the comparisons come in. So what I want to do is I want to look at the x's and the y's separately, and I want to compare them. Which one has a bigger exponent, x to the 6th or x to the 7th? Or excuse me, x to the 1st or x to the 7th? X to the 7th is bigger. So that means that x has to stay as a numerator. Its numerator is bigger than the denominator, so it's going to stay in the numerator. And then I'm just going to subtract the exponent. So what's 6 minus, and remember there's assumed 1 there, 7 minus 1 is 6. Follow the same rule for y. Which y is the biggest? Y to the 4th or y to the 3rd? Well, y to the 4th is bigger, so that means y will stay as a numerator. And I'm going to subtract 4 minus 3. What's 4 minus 3? That's 1. So my final answer here will be 2x to the 6th y all over 3. Final answer. So I like to call that the comparison. Most people don't teach that. I like teaching that. All right, so here's the next one. So what in the world we got going on here? Well, the biggest thing I see when I notice this problem is this thing right here. So that means that whatever is here is all 1. So that means that's going to cancel out to equal 1. And that negative doesn't go away, so that's negative 1. So then I have to apply this negative 2 to everything inside this parenthesis. So that's going to be times 4 to the negative second power, x to the negative second power, y to the negative second power. And now's where I have to simplify. Anything, remember I told you, anything with a negative exponent has to move. So we're going to treat this as if it's over 1. And remember, only the negative exponents move. So that means this has to move. This has to move. And this has to move. The negative 1 stays right where it's at. So then this becomes negative 1 over 4 squared, x squared, y squared. And then all I've got to do is simplify any numbers that will simplify. So I've got negative 1 over 4 squared, which is 16, x squared, y squared. Done deal. And so I hope this helps you with the lesson. I know there's a couple that I didn't kind of go over, but they're similar to one of these other examples. So use one of these other examples to help you. So if you're still struggling with exponents, please take a few minutes to make an appointment for a help session. I can sit there and go through some of these with you. And send me a teacher message otherwise, and I hope you have a great day.